Alright, we are looking at geometry CST review. Remember, this is the geometry stuff that we're really taking a look at. And this one is more geometry than almost anything else. It's things that are very specific to it, constructions and transformations. You do a little bit of transformations in other classes, but constructions, this is the only place you're going to see that in this class. So let's go ahead and jump right in. Number 64, the first one dealing with it. Okay, so I look at this as Marcia is using a straight edge and a compass to do the construction shown below. Which best describes the construction that Marcia did? Okay, now here's the thing about constructions on a multiple choice test. Constructions are hard to grade or assess on a multiple choice test because it's so easy to find shortcuts. All that I really have to do is kind of see what is it going to be. So I see right here this looks like an angle and it looks like there's another angle. And in fact, if I were to take this point and connect through here, these look like they're copies. It's like a corresponding angle. So that's kind of looking like what's happening. But then I look down here and it says align, 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 align. Okay, so it's not copying these angles. But if these angles are copied, that would be like corresponding angles. And corresponding angles, if corresponding angles are congruent, then we're going to get parallel lines. So now I think I have something that's happening. So is this a line through P right here that's parallel to line L? I think so. This line up here that I just drew in black, let's do another color here, that I'm doing in blue, this line is going to be parallel to this line. So we're looking at a line through P that's parallel to L. That looks like it's the right answer, but just to make sure, let's go ahead and eliminate the other ones. A line through P intersecting line L. That doesn't look like what's happening. That would mean that the line does this and comes down here. That's not what's happening. It's not going to intersect. It's not intersecting. So that would be wrong. Similarly, a line through P that's congruent. Okay, for it to be congruent would mean that they're the same length. And that's not true either. Perpendicular. Okay, perpendicular means right angles. And these are definitely not congruent. They are not perpendicular. And they're not intersecting. So all three of those are out. Boom, boom, boom. Answer's A. Cool, 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 cool. All right, given angle A. What is the first step in constructing the angle bisector? Okay, we're going to look for an angle bisector. So it's asking me for the first step. Well, if I'm given angle A, I'm not going to draw AD. That is the last thing. This is the angle bisector. That's the angle bisector. And that's the last thing that I want to do in that process. Okay, so draw a line segment connecting points B and C. Well, that's not even done. There is no line segment connecting points B and C, so that's out. So is A. All right. From points B and C, draw equal arcs to intersect at D. Well, that looks like it happened. In other words, they took an arc here and then drew this arc there. They took an arc from B and drew that arc there, and then they got this intersecting point. From point A, draw an arc that intersects the side. So that first one is look like it's either C or let's look at what D would be. D would be to draw this arc there. Okay. Well, what would you have to do first? Well, in order for me to have points B and C, I have to draw the arc first before I even have B and C. So at the angle at points B and C. So this right here, this creates points B and C. And C here creates point D. So the question is, which one comes first? Well, the answer is D. And that means that you got to create points B and C first before you can create point D. All right, so there's that one. Now it's a little more complex because it's kind of understanding the whole process, but just try to ask yourself, could I do this option C before option D? And that kind of gives you part of your answer there. All right, now Scott is constructing a line perpendicular. That sounds like a keyword. Let's think about perpendicular. That means something like this, with a 90-degree angle. To line L from point P. From point P. All right, that's kind of interesting. So it's kind of asking us, what's doing that? Which of the following should be his first step? So if I were going to construct a line that is from point P perpendicular to this. Well, this one looks like it's going to be perpendicular, so maybe that. Not sure quite yet. This almost looks like something here, and in fact, I'm pretty sure that the answer is D, and here's why. Because let's say I started by taking this and making an arc here. Then I have these two things, and now I can draw some circles. I want to show you how I would draw these circles. So I would take a circle from this point, and I would have to, oh, that's kind of hard to see that way. Let's do it this way. Here we go. I would have to take a circle, and it would look something, no, it's not like that. We'll make that clear. There we go. It'd be going through P, but then it would have a center at that other point, right about there. So it looks like I would make this kind of arc, and then I would make that arc, I would duplicate it here, and then, ooh, look at that. Then I could draw a line perpendicular. So what's the difference between A and D? Because both of those seem to have that symmetry balance. The answer would be D. And it's because in order to make it go through P, I have to connect P to the line somehow, and that's done with this arc. Now these ones happen to do that, but we wouldn't get those tick marks. Those two circles are the same thing as these tick marks that were made there. And that's why D would be first. Okay, so what's going on with B here? And honestly, this is something that you could do the way that it has here in B. It's saying that you can make an arc here and an arc here, and then you could make another arc from this one and cross through there, but go all the way down here. And you can make an arc from this one and go down through there as well. So now, oh, this is kind of interesting. That means I could do B, C, or D. I think D would be the easiest, the most straightforward way. But B and C are still viable options. So honestly, this is not really a fair question. Because it even says here, which of the following should be his first step? Well, it really depends on what method you want to use. I would probably choose D, just because that's one that stood out to me. But honestly, all three of them could work. All right, let's do this. Oh, you know what? I can cancel out B. Here's why. Because there's an implication that this distance here is the same as this distance here, that these are congruent, that somehow I magically picked these two pieces so that they were symmetrical. So B is out, that's out. Similarly, for me to make this kind of arc that I'm doing here for C means that I'd have to equally space it on the other side. So that one's out as well. That's why those are out. They don't have that automatic symmetry. This arc creates a symmetrical balance, and that's why we can get it right through the middle and then make those two arcs and make it perpendicular from there. Okay, what triangle can be constructed from this? Okay, now it helps to actually see the picture, but here's what's happening. First they put the tip on A, then they make this arc here, and then they say, oh, then I got to go to B, and then, which is on the line, and then I got to make this arc here. And then from those 2 points that we started from, we can connect this, we can connect this, we can connect this, and then we make a triangle. And the question is, what kind of triangle did we just make? Well, if these 2 circles have the same radius, which is implied here, let's see, without changing the openings. So that means the 2 circles are the same. Then that means that this radius is equal to this radius. So I at least have an isosceles, but here's the crazy thing. Look at this. That's another one of those radius. So we have 3 equal sides, so we're not a right triangle, we're not obtuse, we're not scaling. We're equilateral. That's an equilateral triangle. That's what we constructed. Let's look at number 68 here. What geometric construction is shown in the diagram below? So I'm going from B to here to here. So that means that this and this are congruent. And in fact, if I do it on the other side with A, those are congruent. And then this down here, this is congruent, this is congruent. And then, so we got a lot of balance all over the place, which means that this piece here is congruent to this piece here as well. So those two pieces are equal. They're equal. 2 equal pieces. Now the word that is happening there, that is an angle, or that's not an angle, it's a segment bisector. It's a bisector. So I need to look for something with a bisector. Line parallel? Pfft, yeah, right. Angle bisector? Close, but we're not bisecting an angle. We're bisecting a line. So if that said like a segment bisector, that would probably be true. An angle congruent to the given angle. Technically, we kind of did, but that's not really what it was going for. It was going for this dotted line down the middle. I'm going to color here in red, so that's the line it was going for. So that one I think is out too. But perpendicular bisector. So then the question is, does that make a perpendicular line? Well, sure, looks like it. In fact, it does. It does make a perpendicular bisector, which you could show from some more proof in there. But it's a perpendicular line that bisected another segment. Check. Perpendicular bisector. Number 93. All right, now we're going into transformations. Transformations is all about taking some numbers, doing some math, and then getting new numbers. That's pretty much it. So let's see what math is happening here. It says triangle ABC. Oh, so we start with this 2, 1, 3, 4, 1, 3. You know what? Let's go ahead and let's draw that. So I got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. And we're looking at movement, you guys. This doesn't have to be perfect in the picture, but let's go ahead and try to draw it semi-accurate here. 2, 1 for A. 3, 4 for B. And C is 1, 3. So 1, 3. There's C. And it makes this triangle. Okay? It's translated 1 unit down, and 3 units to the left. So we got to go 1 down and 3 left. 1, 2, 3. So here's your new A. And then C is going to be 1 down and 1, 2, 3 left. So there's C. And B would be 1 down and 1, 2, 3 right. There we go. So it shifted. It went down 1 and left 3. And it's asking us, what are the coordinates of the vertices D, E, F? Ooh, okay, that's kind of interesting. Let's see. Visually, we can see that A, or whoa, that's not A. This would be, what do we got? This would be D, E, this is F here, and this is E. A, B, C, D, E, F. Okay, so D would be -1, 0. Hey, there's our answer. Because all these other ones are wrong. Looks like in B they just got the two pieces here mixed up. So pictures really help with transformations. They really, really help. I really suggest using them. Let's look at the next one. Next one here is 94. Ooh, this is a little different because it says rotated 180 degrees. Okay, so rotated 180 degrees, think about a circle, and if you're here, then you're going to go to the exact opposite side diagonally down. You're going to pass right through the middle there. So it's kind of like if you were right, let's say this was 3 and 2, well now it's going to be -2 and -3, pretty much. You just make your numbers negative, you rotate down to the bottom. So right here, this C is going to become -1, -1 here. That's like a rotation. And B was at 3 and 4, so now it's going to be at -3, -4. And then A was at 5 and 4, so now it's going to be at -5, -4. So there is our 3 new points. This inside one, that's our C, and this closer one to the middle is B, and then we have A. So what's the question? What are the coordinates of the new A? A prime, when it says prime, that's like the new version. Okay, well A looks like it was down here, -5, -4. There we go, it's the first one. That was easy. Eliminate the other ones. Cool, no problem. So that's a good thing to see in the symmetry of a rotation. When you're doing a 180 degree rotation, means change the sign. Change sign of both X and Y. Okay, let's look at this next. Number 95. ABCD below is translated to trapezoid ABCD by the following motion. Okay, so here's where you start. You're going to add 3 to your X values and subtract 4 from your Y values. So let's do it one at a time. Let's look at A here. A, we're going to add 3 to the X. So that's 1, 2, 3 to the right, and subtract 4 from the Y. So 1, 2, 3, 4. There's our new A. Let's do this color-coded. Let's go with B now. B was here. We're going to add 3, 1, 2, 3, and then down 4. There's the new B. There's the old B. Let's do purple. Okay, so purple for D. Then we would go 1, 2, 3 we added, and now we're going to subtract 4, which means 1, 2, 3, 4 down there. Then the last one, you could almost predict it. C starts here at 5, 1, so it's going to go 1, 2, 3 over to 8, and then down 1, 2, 3, 4 to -3. So now we have this new trapezoid. What's the question? What is the question? What are the coordinates of C? Well, C was here, and now it's here. So that's at 8, -3. Boom. The answer is D. The other ones are out. I don't even know why they're wrong. I think the other ones were probably actually wrong because these are different ones. 1, -3, that is D prime. B, 2, 1 is A prime. C, 6, 1, that's B prime, but it was asking for C prime specifically, which is D. All right, next. The expression describes a translation from here to here. All right, well, let's look at this visually because pictures really help. -3, 4. 1, 2, 3, 4. So there's the first point. Let's call this P. And then 4, -1. So we're going 1, 2, 3, 4, and -1 down here. So here's P prime. And what we're really looking for is what's the translation to get from one point to the next. Okay, so we start up here at 4. We go down to -1. So that's 4 on top, 1 on bottom. That's going to be 5 down. So that automatically cuts out B and A because that said 5 units up. And then we go, well, it must be 7, but which way are we going? We're going 7 to the right. Because remember, it said from here start to here finish. So you got to interpret those numbers from here start to here finish. Okay, and so we're going 7 units to the right. D, not left. Okay, that's good, and that's all of them. We are done. Happy stars, great day, and I hope you guys do well in the CSTs. Good luck.